Hello everyone, today we are going to review CoPrint and we'll take a multicolor print with Artillery Sidewinder X1. First of all, what is CoPrint? CoPrint is an add-on 3D printer component. With CoPrint, you are able to take up to 7 multi-material or multicolor prints. Let's continue with the ingredients of the CoPrint box. These are what you will get when you buy CoPrint. If I have to say the ingredients, CoPrint itself, connecting feet, 7-in-1 module, direct drive part for Artillery Sidewinder X1, Pitfall tube, fittings, limit switch, step motor cable, an SD card, an SD card reader, bolt and nuts, Allen keys, and finally we have the power supply. Let's take a look how to assemble CoPrint to the Artillery. Assemble of the CoPrint to the Artillery Sidewinder X1 requires simple 9 steps. These are fitting assembly, feet assembly, Pitfall tube connection, direct drive deactivation, direct drive cover assembly, step motor cable connection, limit switch connection, power supply connection, and finally calibration. Let's start setup with these steps. First, fitting assembly. Fittings are required to keep Pitfall tubes in location. We must tighten fittings to the CoPrint, 7-in-1 module, and direct drive cover. Second, feet assembly. Feet are required to assemble CoPrint to the 3D printer. These feet will be connected to CoPrint with M4 15 volts. As you can see, I already prepared this step. After that, M5 10 volts and T-nuts will be used to mount feet to the 3D printer. In order to do that, we have to remove the filament holder first. Third, Pitfall tube connection. Pitfall tubes will be used to guide filaments. These tubes will be fitted to the CoPrint and 7-in-1 module. Length of these tubes must not block the movement of the hot end, so we must cut them considering your 3D printer Z height. after the fourth step, we will connect the last PTFE tube to the direct drive part. Fourth, direct drive deactivation. Since this 3D printer has the direct drive system, we have to deactivate it in order to use CoPrint. In order to deactivate the direct drive, we have two bolts that located left side of the head. These must be removed. After that, we have to remove the tightening bolt. With that move, extruder gears and latch will be off. After that, we have to remove the PTFE tube that goes into the hot end. Fifth, direct drive cover assembly. After deactivating the direct drive system, we have to assemble the direct drive cover, which comes with the CoPrint. This process requires two pieces, metric 320 bolts. These bolts will be tightened to the same place that we removed the bolts from the direct drive system. After we finish the assembly of the direct drive parts, we have to insert the PTFE tube inside the nozzle. So, the default length of this PTFE tube is 103 mm. But be aware that when you cut the PTFE tube in appropriate length, you have to remove the PTFE tube and measure the length of PTFE tube that you cut. This is must. Because of that, in the CoPrint application, you have to insert this value. Sixth, step motor cable connection. In order to extrude filaments from CoPrint, the step motor cable of the 3D printer must be connected to the CoPrint. Extruder gears on the CoPrint are driven by the 3D printer. So, the motor cable on the 3D printer must be connected to the CoPrint. Since Artillery has very small motor cable, this has to be replaced with the motor cable that comes with the CoPrint. Seventh, limit switch connection. The limit switch is used in our system in order to understand filament has to be changed. The limit switch has to be replaced at the end of x-axis. In 3D printer commands, we can send the hot end at the end of the x-axis. In this case, our recommendation is 262 mm. 8. Simply, the power supply cable must be connected to the coprint. 9th. Since the extruder motor has changed, the new extruder calibration must be handled to take preferably good prints. Now we come to the last step. This is calibration. For the calibration step, we have to use a program called Repetier Host. This program is open source program, so you can download it from Google. As you can see, I search for the Repetier Host and I can see download now button. When I click here, the Repetier Host program will be downloaded to your computer and you will be open the program. As you can see, I already downloaded and opened it. After that, I have to connect my computer to my 3D printer. For that, you can use a USB cable. As you can see, on the left top side of the page, there is a connect button. When I click here, it gives a warning that COM11 is not connected. When I say yes, it will be open a page and I can select a COM in here. This is a port that's called COM, and you can select your COM from here. In fact, you have to select because when you change your USB connection port, this COM port will be changed. So I will be click COM3 and I will save my settings. Now, for the calibration, I have to read the EEPROM values from our 3D printer. For that, I can do a research from Google as a EEPROM E-step reading Marlin. I will be clicking the first page and I will be searching. As you can see, the M500 code will be saved and M501 read all parameters from EEPROM. This is what we are looking for. I will be reopen the Repetier Host. From there, I will click connect button after I change the COM button. Now, as you can see, our computer connected to our 3D printer and I can write a Gcode. This is M501 in this case to read EEPROM values. I read it and I will click send button. As you can see, we can read all these values, COM offsets, PID tunes, and acceleration units. This is what we are looking for. Steps per unit. There you go, you found it. In the steps per unit label, as you can see, there are 4 steps that indicate X, Y, Z, and E axis. E called as E step motor, which is extruder. I read this value as 445. Now, in my 3D printer, I have to send a 100mm filament and I have to cut this filament when it's done, the extrusion is done, and I have to measure it. And I can do this extraction by using this Repetier Host program. As you can see, on the right side of the page, there is a label which indicates nozzle, but be aware that before the extrusion we have to heat the nozzle, and I can use this program. As you can see, it indicates 200, but it is connected to 26 degree right now. So I will be click this and I will change it as 200. Bir daha kapatmamız gerekecek buraya. Tamam. Tamam, şurayı tekrar alıyorum. Be aware that before the extrusion we have to heat the nozzle, and in here I can write 200 degrees Celsius, and I have to click this button to open the nozzle. When I click here, as you can see, the program sends a G-code, and this code indicates the nozzle must be heated to 200 degrees. Now our extruder, our nozzle, is heated to 200 degrees Celsius. We have to send 100 millimeter of filaments, and we have to cut the filaments when the extrusion is done. After that, we will read this measurement, the filament extrusion, and we will save it. Now I have to insert a filament to co-print. As you can see, I have filament here, but I have to change the tool from first to second because I cannot put the filament through this place. I will click change tool. I will select second. In fact, I can select seventh to make it more easy. As you can see, it turned to 7 extruder. Now I am putting it in. Finally, I put the filament through all, and I come back to first. Now, as you can see, there is a much more filament than I expected, so I will cut this. As you can see, it's seamless, and I will send 100 millimeter from my computer. It's really fast and it's going. As you can see, this is much more filament than I expected, and my vernier caliper is not able to measure this long, so I will be using a meter for that. As you can see, I come with longer measurement device, and it's approximately 27.5 centimeter. I will record this value from my computer. I will open a notepad, and first extruder is 27.5 centimeter, which is equal to 275 millimeter. Now I am coming with second extruder. Now from co-print, again I have to select the second extruder, but be aware that I change it to second, but again I am not able to put the filament through all the way because the gear mechanism is blocking the way, so I changed it as a third, and I'm putting the filament through. Now it's okay, it's seamless. Back to second again. Now again I'm sending 100 millimeter more. It will show up much more. I cut it through the way. I'm measuring it again. It is 27.1 centimeter. I record this again. 27.1 centimeter, which is equal to 271 millimeter. Now third extruder. Again I am selecting the fourth, and I am putting my filament in the third section, and back to third. Yes, it's seamless. I'm sending 100 millimeter more. Now I will repeat all these steps through all 7 extruders. Now we have finished all 7 extrusions. As you can see, I record all values and I take an average extrusion value, which is 275.25 millimeter. This is too much because the artillery has an enormous amount of A step value, which is 445, as you remember. Now we have to make a calculation to calculate new A step value. As you can see, we have our equation here. If 445 millimeter per second extruder value is equal to 275.25 millimeter, which number equals 100? When we solve this equation, we can easily see that 163.45 millimeter per second has to be our new extruder value. In normal cases, we can send a Gcode from Repetier host program to our 3D printer and save this value to the EEPROM. But unfortunately, in Repetier host program, we are not able to do this. Instead, saving this value to EEPROM, we will write this Gcode to our Pursa Slicer program. But to show you, I will send this Gcode, this value of Gcode actually, to our 3D printer, and I will take an extrusion of 100 mm and we will see result together. For that, I am opening Google again. As you can see, I cannot read any value and I cannot see that what should I write as a Gcode. So I am clicking M501 and as you can see, there are default Gcodes that does a lot of things actually, but I'm looking for specific Gcode that M92. As you can see, M92 is set axis step per unit. I'm scrolling down. Here's the example. Sending an S step value to our 3D printer via using Gcode is like that. I will copy this code to our program Repetier host and I will paste it Gcode section, but instead of writing 688, I will copy this value or 163.45 and paste it here, but remember that this has to be dot, not comma, okay? And I will send this value and I'm seeing a message that I received this value. Now when we send 100 mm of filament, it will extrude exactly 100 mm. As you can see, now I am cutting the filament. I will measure it via using my digital caliper and hopefully the result will be 100 mm. As you can see, it equals the 101.32 millimeter. In this case, I will repeat the whole equation again, but for this time 101 millimeter. Back to our notepad If we have 163.45 millimeter per second, and this gives us 101.31 millimeter, what should I write for 100 millimeter? I will change this section here again, and I will divide it to 101.31. Open a calculator. 100 multiplied by 160.45 and divided by 101.31. As you can see, our value, that standard value, 163.45, but our new value is 161.33. I will be right here to save it. 33 is good for us. I will paste. Remember that M92 E for extruder, of course, 161.33. 161.33. I will send the Gcode again. Extrude 100 millimeter again. Okay. Let's observe the results. As you can see, our value is 99.80. This value is in our tolerance values, so you don't have to worry about 1 millimeter or 0.5 millimeter. This extrusion value, as you can see, actually 100.5 or 5. It's really good. And with that, our extrusion calibration is completed. Now we can take a multicolor print. Finally, we have finished the extruder calibration. Now we have to set up our copying application and Pursa. After that, we will take multicolor print. Okay guys, right now we are going to set up the coprint application and Pursa slicer for coprint. For this we need coprint application setup exam. As you can see, we have here named as coprint. By double clicking here, I can pretty much set up it to my computer. I can select language. I will select English to be more understandable for everyone. Right now it asks me to destination location, which means that I can set up my coprint exam with any direction that I desire. But right now, inside of the coprint files, inside of program files, actually, it's pretty much okay with me, and it will create a folder that named as coprint as well. Yes, I like to create a start menu folder named as coprint, and yes, I would like to create a desktop shortcut named as coprint. I do not want to initialize coprint right now because I would like to show you the inside of the folder. Let's see what we have in here. I can directly open my computer, see program files, and I can see the coprint in here. Inside of it, you can find the coprint user manual, the coprint application itself, coprint Pursa slicer, an uninstall, and you can find coprint slicing setup. Let's open Pursa slicer and slice a multicolor print. Now, as you can see from my computer, I already insert our model to Pursa Slicer. I can paint it after I clicked, and as you can see on the left side of the page, we have multi-material painting. In your file, the extruder colors are already set, but we can change it from printer settings. As you can see, there are 7 extruders, and on the extruder, when I click the extruder 1, extruder 2, extruder 3, in the preview section, we have extruder color. I can set these by clicking and selecting color, such as the first color I will pick red, and for the second, let's see what we have. Green we can select. After that, yellow. For the fourth extruder, we may select, let's see, an orange. Okay. Pretty close. For the fifth extruder, we can select blue, but it's pretty light. The dark blue will be our 6th extruder color, and finally we will paint our 7th extruder to the white. Okay, after the plater, the first, as you can see, I can select first and second extruder, or only 7th extruder, and these will be these colors will be set to my left mouse button and right mouse button. These are macros that Pursa Slicer provide us, and I can select Smart Fill in here, and as you can see, I can paint it by clicking the yellow color, the orange, light blue, dark one. Okay, back to white. As you can see, the sides are important. I will paint them to the white. Okay, let's see under our model. Okay, our first color was red, green, and yellow, and orange. Blues are coming. Okay, I think we are done. Yeah, we forgot the back side of the model. Okay, we forgot here too, painting white. Anything else? Yes, finally we are done. After painting the model, I can click slice now, and as you can see, our sliced 3D model appears here, and this is cleaning tower. I can adjust the cleaning tower point by dragging it, basically. Okay, let's turn back it. And as you can see, the estimated printing time is 1 hour and 44 minutes. Okay, now I have to export the Gcode. Now we have to modify our Gcode file, which is our Pursa Slicer output, and for that we have to go back to computer and edit our Gcode. So as you remember, I already said that because of the artillery settings, we cannot save our step value, so we have to initialize it on the process slicer. I'm going to printer settings, and as you can already see, there is custom Gcode and start Gcode section. I already write the value, which is M92 space E161.33. This is sets the extruder step value. After you write it here, you can slice the file and you can click the export Gcode. I already saved it, but let's save and rewrite it. Okay. After that, I will open our copying application. But as you remember, I already mentioned about the filament, the Pitfall tube length, and as you remember, I said that we have to measure our Pitfall tube length, and according to this length, we have to change some values on the copying application. On the right hand side, we can see some values that filament retraction length, filament feeding length, and limit switch position. First of all, let's deal with the limit switch position. As you remember, we said we located the limit switch at 262 on the x-axis. So I rewrite it as 262. And these filament retraction and filament feeding lengths are defaulted for 103 mm Pitfall tube. But in our case, I set the Pitfall tube length, I cut it to the 119.8 millimeter. So I have to add 119.8 minus 103, which equals to 16.8. So to these values, to filament retraction and filament feeding lengths, I have to add 16.8. 94 plus 16.8 is 110.8. 108 plus 116 point that is 124.8, and we already changed our limit switch position. After set these values, I click the open Gcode file, and from desktop or whatever you save the Gcode file from Pursa Slicer, I select it. As you can see in here, rainbow. I open it, and I am saving edited Gcode file. This file will going to the 3D printer. So I will name it as rainbow 3D printer. Actually, you write it like that, printer, and I save it to the desktop again. And I'm saving copying file. Let's save this as rainbow underscore copying. Okay, I save it. Now, first of all, we have to look the file that we saved as copying file, which is a text file. When we open this file like that, we can see some numbers. These numbers are actually the extruder values. As you can see, our print starts with 0, which indicates that the first filament will be extruded at the beginning of the print. So what I have to do is I have to insert the first filament, in our case is red, through all the nozzle, and I have to see that the filament is extruding. The other filaments must be located at the beginning of the 7-in-1 module. As you can see, the blue filament is not located in right position, so I have to insert it more, and when I see that there is a 1 or 2 millimeter space between fittings and filament, I will stop and I will adjust all the filaments as same. I guess it's done, and let's preheat our 3D printer to 200 degrees Celsius. Okay, and when our 3D printer heated, I will extrude manually our filament, but be aware that you have to change the tool from co-print, because initially co-print holds the first filament, so you will not be able to insert filaments manually. From tool change, you can select second or third or any else that you want to extrude, and you can, after that, you can insert filament through the all the way in. Okay, our extruder at 200 degrees. Now I'm going to set in the extruder tool change. I will select 3, and when I push the filament manually, I can see that filament is extruding. From now, I will stop recording and I will set the camera and we will start printing.